Welcome to ETABS, an extremely versatile and powerful object-based program with many features and functions for the analysis and design of buildings. ETABS is a standalone finite element program that works off an integrated database, so that you need only create one model consisting of the floor system and the vertical and lateral framing systems to analyze and design the entire building. All options are accessed through one interface, and there are no external modules to maintain or transfer data to. This tutorial will illustrate the fundamentals of working with ETABS and will show how quickly and easily a model can be developed. At the completion of the tutorial, the building shown will have been created, analyzed, and designed, so let's get started. Our project will be a 4-story building where the first story is 15 feet and the remaining stories are each 12 feet high. The bays are all 24 feet by 24 feet. The lateral system will be a steel moment frame. No beam may exceed a depth of a W18. We start by setting the building grid and story dimensions. Check the box in the lower right corner to make sure the units are correct, in our case kip inches. Click the File menu, New Model command, and on the New Model form, select No, as our model will be completely new. The building plan, grid system, and story data form is used to specify our grid line and story data. Set the number of stories to 4 and type 15 feet for the bottom height. The program will automatically convert to inch units. Select Grid Only and click on OK. Our building grid is complete. Next, we will define an auto-select section list, which is simply a list of sections that may be assigned to frame members. When an auto-select section list is assigned to a frame member, the program can automatically select the most economical, adequate section. Because we are restricted to a maximum beam depth of 18 inches, it is useful to create an auto-select section list that contains W16 and W18 beams. Click the Define menu, Frame Sections command, and on this form, click the drop-down box, Add I Wide Flange. Scroll down until you find Add Auto Select List. Type AutoLat Beam for the list name, and scroll down on the list of beam sections until you find W16 by 26. Click once on this beam. Scroll down further until you find W18 by 175, and holding the Shift key, click on this beam. Then click the Add button to add the selected beams to the Auto Selections list, and click on OK. Now we will add line objects to multiple stories. These line objects will represent our columns and beams. First, make sure that the plan view is active. You may do this by clicking anywhere in the window. Next, click the drop-down box in the lower right corner that reads One Story and select Similar Stories. To review these definitions, click the Edit menu, Edit Story Data, Edit Story command. By default, the program has defined Story 4 as the master story, and Stories 1, 2, and 3 as similar to 4. This means that any drawing or selection performed on one story will apply to all of the other similar stories. Next, draw column objects by clicking on the Create Columns in Region or It Clicks button. Make sure that the property item is set to ALAT Call, which is a built-in auto-select sections list used for lateral force-resisting columns. Click in the Angle Edit box and set the angle to 90 degrees. To draw the first column, left-click at the intersection of grids D1. Note that the column is displayed over all 4 stories because of similar stories being active. We will add another column at D2. Now change the angle from 90 to 0 and draw the remaining columns in one action by windowing using a selection box. Click the Select Object button and holding the Control key down, click in the plan view on column A2. Select the column in the list and note that the status bar in the lower left corner indicates 4 lines have been selected. Repeat the process at B2, A3, C3, and C4. The status bar should show 20 lines selected. Click the Assign menu, Frame Line, Local Axes command, and select the Major Direction is Y option. The selected columns rotate 90 degrees. Notice that the local axes of the columns are displayed. These axes may be shut off by clicking on Assign menu, Clear Display of Assigns. During development, make sure to save the model often by using the File menu Save command. Next, we will draw the lateral force resisting beam objects. First, make sure that the plan view is active. Click the Create Lines in Region or at Clicks button. Click on the Property Edit box and scroll down to select Auto Lat Beam, the Auto Select Sections list we created and named previously. Left-click once on grid line D between 1 and 2, and note that the beams are created at all levels due to similar stories being active. Draw beams on grid lines 1 and 2 in a similar manner. Now draw the remaining beams in one action by windowing around the grid lines using the selection box technique. Click the Select Object button and left-click once on the beam located on grid line C. This selects the beams at this location for deletion. Now we will draw the secondary infill beam objects. Once again, make sure that the plan view is active. Click the Create Secondary Beams in Region or at Clicks button. Make sure that the property item is set to A Comp Beam, an auto selection list for composite secondary beams. Left-click in the bay bounded by C, D, 1, and 2 to draw the beams. Draw the remaining infill beams by windowing around the other bays. Next, go to the Select menu using Intersecting Line command. Left-click the mouse next to the beams to be selected, and while holding the button down, drag across the beams. The selected beams may now be deleted. In this step, floors will be added to the building by drawing floor area objects. Again, make sure that the plan view is selected and click the Draw Areas button. Check that the property selection is Deck 1. Also check that the Snap to Grid Intersections and Points command is active. Click once at column A1 and every other corner as you move clockwise around the model to draw the outline of the building. Press the Enter key after returning to A1. Note that the two-headed arrow indicates the direction of the deck span. Click the Select Object button and then the Set Building View Options button. Make sure that the Object Fill effect is selected and applied to all windows. Next, click the Define menu, Wall Slab Deck Sections, and click on Deck 1. We will modify the slab depth, TC, to 3 inches. Now we will add some dummy area objects that have no mass or stiffness to the model to be used for the application of a wind load. We will add the first of these objects in an elevation view. Set the 3D view as active and click on the Elevation View button. Select Grid Line A and click OK. Click the Create Areas at Click button and select None from the drop-down Property Edit box. Click once in each of the bays to add the dummy area elements. Change the elevation view back to a plan view and select Story 4. Click the Create Walls in Region or at Click button and click on grid lines C, B, and D. To add dummy walls in these bays at all levels due to the Similar Stories feature. Click the Select Object button to return the program to the Select mode and change the right window back to a 3D view.